This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on limits. So if we have a function f of x, if f of x gets arbitrarily close to a value L as x gets close to a, but not equal to a, we say that the limit of f of x as x approaches a is L, written like so. The lim for limit, underneath it, x approaching a is written x arrow to a of f of x equals the value L. So to get a better feel for this idea, we'll consider this graph. We have a function drawn here in blue, and on the x-axis we have a point marked with a, and on the f of x axis we have a point marked L. So the idea is, if we define a little space around a, and we look up at the portion of the curve that is associated with this little space around a, we've highlighted that here in green, and then if we look at the f of x values associated with this little green portion now, we can see that it defines a little area around the value L on the f of x axis. And the idea is, if we make that space around a smaller, we want the space around L to also become small. So if we make this space around a get a little bit smaller, here we've made it a little bit smaller, you can see that the green portion is smaller. And when we look over the f of x axis where it corresponds, it's gotten smaller around L. So if we make that little space around a get as small as possible, as we do that, if the space around L gets arbitrarily small, then we say that the limit as x approaches a of f of x is L. Now let's consider the following graph. We're going to look for places where the limit exists and where the limit doesn't exist. And we have two areas of interest, or two spaces of interest. The first at x equals 0 and x equals 2. So let's look at x equals 2 first. Right here at x equals 2, we see the value of the function as it's getting close on the left. All these values are kind of getting closer to this value at -3. And if we look on the right, all the function values leading up to 2, x equal 2, are also heading up to -3. So these two sides, the function value, are matching up. So we say right here, the limit exists at x equals 2. Even though the function is not defined at x equals 2. Then, if we look at x equals 0, something a little bit different is happening here. The function values, as x approaches 0 from the left, are heading to this point of 0, a function value of 0. But if we look from the right, the function value approaching 0 leads to the point -2, and these don't match up here. So we say that the limit does not exist at x equals 0.